So we're looking at continuity and differentiability. So continuity of a function is where basically it's on a line. So there's a point and it's following as part of a line. So if three conditions have to happen for it to be continuous. First of all, f of a has to be defined. So at this point x equals a, we can see there's a value, there's a solid dot at this particular x value. What has to happen too is that the limit from below and above has to exist. So when you're looking from coming from above and below, that has to be going to the same point. And also that this limit is actually the same as the actual value as well. So it's any point that's on a line is a continuous. So we're talking about differentiability, is that we're looking at a particular point. Now if we look at this point here from P to A, this tangent here, that slope is the same as that tangent at that particular point. So the slope of PA equals the slope of B. But if you notice on the second graph is that if we look at this point P and we're looking at on this first part of the graph, if we do the tangent at point P on that part of the graph, you can see that it's different than the tangent or the gradient of the tangent at that particular point of the graph. So from the upper side of it. So slope of PA is not equal to slope of PB, and that makes it not differentiable. So the first graph is differentiable at x equals x naught, and the second graph is not differentiable because those slopes aren't the same. So to sum it all up, it's basically when it hits any corners. If it's smooth, it's differentiable. If it hits any corners, but we'll see this in the next slide. Okay, this is some the main areas where it's not differentiable. So if it hits any corners, any cusps, so corners tend to be straight lines, cusps we tend to say on a curved line. Now for this example here, at some point there, it's going to hit a vertical tangent. It is also not differentiable at that point. And for this one here, any one that it actually jumps in the graph, that's not differentiable as well. Now all three of those are continuous, the corner, the cusp and the vertical tangent. However, the last one is not continuous as well. So if we have a look at this one here, right, at this point here it's not continuous because there's a jump in the graph, and it's also not differentiable. Now it's also not differentiable at this corner either, but it is continuous. So to summarise it, when it's not continuous is where there are any jumps in the graph, and when it's not differentiable is when there's any jumps or corners in the graphs.